EUQ on ground motion vector selection for response simulation. My name is Kuanshi Zhong, a postdoc researcher at SimCenter. And first, a little bit information about EUQ itself. The acronym stands for Earthquake Engineering with Uncertain Quantification. And the two is an integrated application that basically has three major functionalities. First, about building model itself, and then in second part is including earthquake hazards through the ground motion tools that's built in the EUQ. And the last part, I think Akash will dive into in the second section. We have some integrated methods from random sampling sensitivity study and also recently surrogate modeling in the EUQ shared with the CoFan backend. And today I mainly want to dive into or focus on one specific problem that can be addressed through EUQ. But first, let's look what it happened currently in our practices. For instance, if I'm interested in my building site in San Francisco, and typically I want to follow up the SE716 method on conditional mean spectral calculation and record selection, then I will first go into a USGS website or other public resources to find out what's the dominated earthquake scenario for my San Francisco site, and also understand what's the SA intensity value at a specific return period, what's the mean and the mean magnitude and the distance from my site to the dominant earthquake sources. And then I will use this disaggregated information into a ground motion prediction equations and with the correlation models to calculate my conditional mean spectra. And from that, I will select records. I can either do that locally via some researchers' applications or directly go into the PeerNJ West to create an account and submit my target spectral download records and continue my structure analysis in later steps. Well, this can be all integrated into our EUQ tool now. So one stop you can, this is just a one interface picture of our EUQ user interface. It has the ground motion table here for target spectral, record selection, and the ground motion downloading table, and also the scaling and the selection criteria. And I'll just zoom into individual boxes here to have some more detailed explanations for each. And for the target spectrum, as we mentioned here, we have the conditional mean spectrum, and this is one of our different target spectral types. And you can have your own site location inputted, defining a VS30 site type, and select which seismic hazard map you want to disaggregate on, and your return period ground motion model to compute this conditional spectrum and the conditional IM intensity measure. And once you click the disaggregate hazard button, it will return a message in the program box to show you the magnitude and distance. And from that, you can use those disaggregated information to help you define what's the filter range in the next box of the record selection. And also in the record selection, you can have the option to define the number of all the ground motions to select and where the ground motion comes from. You can specify in detailed strike slip type, or you can specify whether you want to include pulse motions or not. And other also available options are VS30 of the site and the duration, 5 to 95 significant duration. The last step before clicking the button to select records to define the scaling and the selection methods. So for instance, you can use the minimize MSE method, but also we provide the single peer conditional spectral type of selection, or just without any selection, the raw records from what it is recorded. And then you can also specify where you want to minimize the spectral fitting error through this error weight function. And after that, we will just pull out all the information and send back to PeerNJ West 2 web server. So once you click that button, we'll bring you to a login interface to allow you to continue the ground motion selecting and downloading. And here, just follow one quick example that's for a case study that's using Stanford University classes. So we are let students to really explore what's the dynamic responses for a 4-story still moment frame, and the conditional period of the structure is 1.13 seconds, and we will select 11 ground motion for it and apply some filters to consider the magnitude and distance and the site VS30 effects. And once the student goes through the entire process, and they will finally arrive at the table that's showing summarizing the structural responses results. For instance, in the table here, you will see what's the peak flow acceleration and what's the peak interstory drift ratio for each under each individual ground motion. And our tool can help you to preview the results, either do the histogram graph plots or the CDF, but also you can save the results to CSV and post-processing the results with that data, and to continue your next step, and also integrate it in a later step for damage loss assessment, which will be introduced in much more details by Adam in later. And that's, I think, basically the quick feature review for this ground motion selection and structural response analysis functionalities in UUQ, and just want to end my session with the this slide about more information that you can find through our web portal.